Welcome back. This is my second video on the kinematics equations. If you have not yet seen my first video on the subject, you should head over there immediately. There's the link. That video has most of the most useful information in it. This video is essentially a bunch of footnotes. So first I just want to address the fact that some of you may have noticed a discrepancy between the four formulas that I'm showing you here and what you yourself have seen in your book or in your class notes. There is another formula that sometimes gets included that I'm going to call the fifth kinematic equation. I'll talk about that a bit. Second, I want to talk about the algebra that links all these equations together. In principle, the first equation is really all you need, and I'll give you an outline of how you can derive the other equations from that. Thirdly, I want to address a cryptic remark I made in the last video about initial position versus final position and what that's really all about. And lastly, I'll talk about this term kinematics and explain just what exactly that means. So here's that fifth equation I mentioned. I don't like this equation for a couple of reasons. One is it's too easy to confuse it with the first equation. And two, you really don't need it. Any problem that you can solve using this last equation, you could solve using one of the other four equations or maybe two of them together. So if your teacher includes this fifth equation in your curriculum, I suggest you make a point of trying to solve the homework problems without it, just using the other four formulas. And if you're able to do that, then that means you really don't need this fifth equation, and so that's one less thing for you to have to remember. Second issue, where do all these formulas come from? Well, they come from this. All the rest of this comes directly from this. This follows from this because the derivative of this equation with respect to t is simply this. If you know anything about calculus, you know how to do derivatives, and you should be able to check that yourself. If you don't know calculus, never mind. Regardless, once we have these two, we are all set to do algebra to find the other three. You can get this third formula by solving this equation for a, then substituting into there, and then simplifying a little bit. You can get this equation by solving this equation for t, and then substituting in here and here. And that's fairly involved because this t squared will get a bit messy. Lastly, you can get this formula by solving this formula for v0 and then substituting right into there. And that's actually the easiest one. You don't have to do all this algebra yourself, but I recommend you give it a try because it's good practice. Next up, initial versus final. I told you that's initial, that's final, that's initial, that's final. Well, not quite. If t is equal to 0, then x is equal to x0. At some later time, t is some positive number, and when you substitute in, you'll get some other x value. So that later time will be the final position, and then when t equals 0, that will be the initial position. Well, it turns out that these formulas actually all work even if t is negative. And if you put in a negative t, then the x that you get corresponds to a time before t equals 0. And in that case, this is the initial and that's the final. And it's a similar story with v. So x is the position at any given time t, x0 is the position when t equals 0. Unfortunately, there's no concise way to say that, so I did the sloppy thing and said this was initial and that's final. And most of the time that will be the case. But there's nothing wrong with negative t values, and once in a while you will see them. Last and least, what is this word kinematics, and what does it really mean? It does not mean constant acceleration. The word kinematics is used to contrast this stuff with dynamics. Dynamics is all about force. F equals ma, among other things. There are many different kinds of forces. Dynamics is where you calculate how objects behave under the effects of various forces. Over here, these formulas make no explicit reference to force. They have acceleration, which implies that there's some kind of force, but they only refer directly to position, velocity, acceleration, and time. And when you limit the calculation to those four quantities, we call that kinematics. Kinematics is all about how things move. Dynamics is about why things move, as well as how they move. As usual, please like and please subscribe. If you are interested in being tutored online by me personally, I am available. There's a link in the description down below and also the About page for this channel. And here's a link to my mechanics playlist.